name is Amita, and in this video I am going to discuss about one more topic of in power electronics, that is a three-phase inverter. Dear friends, I hope all of you are aware about the inverter, but those who are not aware, I just want to tell them that it's a kind of power electronics converter by which you can convert a DC supply into a AC supply. As you know that the AC supply is available in two forms. So accordingly, the inverter are of two types, that is the single phase inverter or three phase inverter. Single phase inverter is a type of converter by which a DC supply can convert into a single phase AC. It means the input will be in DC and the output will be in single phase AC. Whereas the three phase inverter is a kind of power electronics devices based converter by which you can convert a DC supply into a three-phase AC supply. There are lot of uses of a three-phase inverter, as the three-phase AC supply is the most preferable AC supply because of lot of advantages of it over the single-phase AC supply, and that's the reason because of it at the each part of the power system we use the three-phase AC supply, whether we talk about some generation or we talk about some transmission and the distribution as well. In this video, I will be mainly focus on three-phase inverter. I will discuss about its construction, its operation and the appropriate waveforms so that you can understand that how the DC supply can be converted into a three-phase AC supply. Now I am sharing my screen and will take you on board where I will explain you each and every detail of a three-phase inverter. Let us start with a three-phase inverter. Three-phase inverter. So the first thing which we are going to discuss about its uses or necessity. So the first point that I can write about it, that it's a semiconductor devices based power electronics converter which converts DC supply into AC supply. That means in case of inverter, the input will be DC supply and the output will be AC supply. In short, I can write that it converts the DC supply input with the help of inverter. We can convert into a AC supply, which will be the output of an inverter. Now, as the AC supply available in two forms, one is single phase AC supply and another one is three phase AC supply. Accordingly, it is called as a single phase inverter and three phase inverter. So single phase inverter is an inverter which converts DC supply into single phase AC supply, whereas the three phase inverter converts DC supply into a three phase AC supply. That means if I show the same thing with the help of diagram, then single phase inverter, the input is DC, that will be like this. If it is T, then this is Vs, it is a DC supply. With the help of single phase inverter, it converts into a AC supply, that is a single phase. So this will be T and this is VO. So the output will be the single phase AC. Whereas if I talk about a three phase inverter, it converts the DC supply, which is constant in nature with respect to time T. DC supply converts with the help of three phase inverter into a three phase AC supply. So three phase AC supply means it is three phase AC supply is nothing but it's a three phases of a single phase AC supply. So how I can represent that, how I can draw the three phase AC supply like this. This is a By red color, I have drawn the R phase. So it is showing the R phase. Then yellow phase, which will start after a delay of 120 degree. So this is Y phase. And at last, I will draw the blue phase. So this is 0. This is 120. This is 180. So somewhere it will be 240 years. So after a delay of 240, the next phase will start. So three-phase AC supply is nothing but three phases of a single phase AC which are delayed by an angle of 120 degree. As you can see here, R phase is starting at 0, whereas Y phase is starting at 120 and B phase is starting at a delay of 240. So the three-phase inverter converts that kind of DC supply into a three-phase AC supply. Now let us discuss about its power circuit diagram. So the second thing is power circuit diagram. Now when I talk about its power circuit diagram, it's to make the power circuit, it requires 6 SCRs. SCRs means silicon controlled rectifiers. We can use MOSFETs also in place of SCR. We can use IGBT also, insulated gate bipolar junction transistor. We can use MOSFET also, metal oxide semiconductor field effect transistors. So any of the device, either silicon control rectifier or IGBT or MOSFET, any of these devices can be used because all these are the controllable devices, and 6 diodes. So total number of devices, number of semiconductor devices which we use to make the three-phase inverter, that are 12, where 6 are SCRs and 6 are diodes. Now let us draw the power circuit diagram. So when we draw the power circuit diagram, it will be like this. This is the symbol for SCR and this is diode. In one leg there will be 2 SCRs. So this is T1, this is D1, this is T4, this is D4. Then there will be another leg of SCRs. This is T3, this is D3, this is 6, T6, this is T6. Then one more lag. So basically it is having 3 legs of SCRs. Each lag is having 2 SCRs. So total number of SCRs used are 6 and 3 legs of diodes. So this is T5. This is D5, this is T2 and this is D2. So here we are supposed to give the input that will be of DC type and this is Vs, and the output of this will be connected to three-phase load. So suppose this is ZA, this is ZB and this is ZC. It is connected to an three-phase star connected balance load. So when it is a load is balanced, load is star connected and balanced. So when we talk about balance, means the impedance ZA and ZB and ZC, all three are equal. So here this is for A phase, this is for B phase, this is for C phase, or I can write it, this is R phase, this is Y phase and this is B phase. Now let us try to understand its operation, how it operates and how it converts the DC supply into a form of three-phase AC supply. Now before understanding its operation, we have to take the assumptions, because the above power circuit diagram converts the DC supply into a three-phase AC supply depending on the operation of an semiconductor devices. So we are supposed to operate these SCRs in a proper sequence so that across the load we will get a three-phase AC supply. So as far as its operation is concerned, we can show its operation in 3 modes. One is 120-degree mode. The 120-degree mode means that each SCR will operate for a duration of 120 degree. Another mode is 180-degree mode. It means the SCR connected to the power circuit diagram of an inverter will operate for a duration of 180 degree. And the third one is 150-degree mode. That means the SCR each SCR connected in the power circuit diagram that will be operate for a 150-degree mode. So in this video, I am going to discuss about the 180-degree mode. Then in the future video, I will show you the operation of a three-phase inverter for a 120-degree mode also, as well as 150-degree mode. So if I talk about the assumptions for an 180-degree mode operation, there are few assumptions. Number one assumption is each SCR conduct for the duration of 180 degree. The second assumption, SCR from the same leg will conduct after the interval of 180 degree. And the third assumption that we have, that SCR from the same group, that is positive group or negative group, will conduct after the interval of 120 degree. Now, I just want to tell what is the meaning of same leg and the SCR of a same group. So let's go back to the power circuit diagram. You can see here that in this power circuit diagram, T1, T4, these two are the SCRs which are connected in the same leg back to back. So T1, T4 are the SCRs of the same leg, whereas T3, T6 are the SCRs of the same leg, and T5, T2 are the SCR of the same leg. So what it means that if T1 is starting at 0, then T4 can start conducting only at 180 degree, because there should be a difference of a duration of 180 degree. So if T1 is start conducting at 0, T4 should start conducting at 180 degree. And now the next thing is SCR from the same group. SCR from the same group means, like if you see T1, T3 and T5, you can see that the anode of these three SCRs are connected to the positive supply. So these SCRs 1, 3, 5, they are connected in a same fashion as for all these three SCRs. The anode is connected to the positive supply. 1, 3, 5, they will be called as a positive group SCR, as they are connected to the positive supply to the of a input. Whereas 4, 6, 2, these are the negative group SCRs, because for all these three SCRs, the cathode of these three SCRs are at same potential and they are connected to the negative of a DC input. So 462 will be called as a negative group SCR, and 135 they will be called as a positive group SCR. And the third assumption is that the positive group SCRs or a negative group SCRs, they will be conduct after an interval of 120 degree. Like if the T1 is start conducting at 0, then the next positive group SCR T3 will start its conduction at 120 degree after a delay of 120. So if T1 is starting at 0, then T3 will start at 120 and T5 will start at 240. Similar way for negative group SCR. So now I am showing the conduction diagram of these SCRs. You can see here in the power circuit diagram that as the input is DC supply, so all the SCRs are forward bias all the time. It depends, the conduction of these SCR will only depend when the firing pulse is given to the SCRs. So now I am drawing its conduction diagram. So when I talk about its conduction diagram, I will make the conduction diagram like this. Suppose this is first leg, as we are having three legs. So first leg, then the second leg, and the next one is the third leg. Now first leg mein the SCRs are T1 and T4. So if T1 is start conducting at 0, then it will be conducting up to 180 degree, and after 180 the T4 will start conducting and it will conduct up to 360, because T1 and T4 they are the SCRs of the same leg, and since they are the SCR of same leg, so if the T1 start conducting at 0, then T4 is supposed to start at 180 degree. Now, as per the third condition, that SCR from the same group should start after an interval of 120. So T1 is the positive group SCR. So now the next SCR from the positive group, that is T3, it will start conducting at 120 degree. And we know that if it start at 120 degree, each SCR is supposed to conduct for 180 degree. So if it is start conducting at 120 degree, then at 180, 120, it will give the 300. So T3 will conducting up to 300, and there is another SCR in this lag, that is 6. So T6 will start conducting at 300 and it will conduct up to 120. So here also it will be T6. So you can see here that in the second lag, T3 and T6 are connected. So if T3 is start conducting at 120, add 180 in this, because each SCR is supposed to conduct for a 180 degree. So 120 may, if we add 180, we will get 300. And after 300, the next SCR of a same lag, T6 will start conducting, and it will also conduct for a duration of 180. So 300 to 360, it will give 60, and add again 120. So for 180 degree, T6 starts conducting. Now the next SCR from the positive group, that is T5. So T5 will start conducting at 240, and 240 say T5 will be conducting up to, we should add 180 in 240. So if I add 180 in 240, it will give 420. So 420 matlab it will conduct up to 60. So this is also T5. So T5 will conduct from 240 to 60, and there is another lag in this another SCR in this lag, that is T2. So T5 will start conducting from 240 to 60, and from 60 to 240, the SCR which is going to conduct, that is T2. As each SCR is conducting for an 180 degree, as we are discussing about 180 degree mode, you can see that T1 SCR is conducting for 180, T4 also conducting for 180, T3 conducting for 180, T6 conducting for 180. So you can see here that with the help of this conduction diagram, we can plot or we can judge the conduction of an SCR. And this conduction diagram we have made based on the assumption, 3 assumptions that we have written above. Now the next thing is conduction table. So what we do, we will write the duration, then we will write the conducting SCR, then we will write VAN, VBN, VCN, VAB, VBC and VCA. Now this kind of table we are supposed to make. What we are going to do, we are supposed to write the conduction duration at an interval of 30 degree. So start writing 0 to 30, 30 to 60, 60 to 90, then 90 to 120. We will write up to 360. So 90 to 120, then 120 to 150, then 150 to 180, then 180 to 210, then 210 to 240, now 240 to 270, 270 to 300, 300 to 330 and 330 to 360. So what we have done, we have written the duration at an interval of 30 degree. Now the next thing is, with the help of conduction diagram, now we are supposed to write the conducting SCR. You can see that between 0 to 30, T1 is conducting, T6 is conducting and T5 is conducting. So the conducting SCR will be 1, 5 and 6. Now 30 to 60 also the same SCR going to conduct 1, 5, 6. Now if you write for 60 to 90, 60 to 90 mein, what are the SCRs are conducting? T1, then T6 and T2. Then again 90 to 120, 90 to 120 mein, again 162, 162. 2. Then 120 to 150, that is 1, 2, 3. We can see 120 to 150, 1, 2, 3. So with the help of conduction table, we will identify the conducting SCR 1, 2, 3. Then 2, 3, 4, 2, 3, 4. Then the next duration 3, 4, 5, 3, 4, 5. Then 4, 5, 6, 4, 5, 6. So you can see that the similar SCRs in each duration, 3 SCRs are conducting, and after an interval of 60 duration, the SCR, one SCR is outgoing SCR and another SCR is incoming SCR. Like you can see 0 to 30, 156, 30 to 60, 156. But when we come to 60 to 90, the 5 will be the outgoing SCR and the incoming SCR will be 2. So now 162, 162. Then again if you see 120 to 150, the 6 will be the outgoing SCR and the incoming SCR will be 3. So 1, 2, 3, 1, 2, 3. So we will get the one particular pattern 1, 2, 3, 1, 2, 3, 2, 3, 4, 2, 3, 4, 3, 4, 5, 3, 4, 5. Then 4, 5, 6, 4, 5, 6 like this. Now the VA and VB and VCN, they are the line to neutral voltages, and VAB, VBC, VCA, they are the line voltages. So let's see 0 to 30, 156 are conducting. So when 156 are conducting, then 156 are conducting means this SCR will be short circuit, 6 will be short circuit and 5 will be short circuit. So when these SCRs will be conducting, what will be the diagram? 1, 6, 5. So what I can do, let me redraw the diagram. As you can see, 0 to 30, 156 are conducting. So let me redraw the power circuit diagram. 156. So what will be the diagram? This is VS. 1 means this will be short circuit. This will be open circuit because this is T1. This is T4. 3 is open circuit and 6 is short circuit. And 5 is short circuit and 2 is open circuit. So 6. This kind of connections will be there. That kind of SCR's conductions will be there. And you can see here that with this is ZA. It's the A phase. With this, the B phase is connected, ZB. This is B. And with this, the C phase is connected, that is ZCC. And this is neutral. Now you can see here, if I redraw this circuit again, this is VS. If I redraw this circuit again, this will be VS. So this T1 short circuit and this T5 short circuit, and these two are short circuited, and with the help of T6 short circuit, this is T6, and this is, you can see, this is neutral. So if I redraw this circuit, I will get like this. T1 ke short circuit se it will be ZA, it will be ZC, this is neutral, and this will be ZB, because T6 short circuit says ZB is connected to the negative of the supply. Now this is A, this is C, and this is B. So this VS voltage is connected like this. Now these two impedances, they are in parallel and series with this. So if for a balanced load, if I consider ZA, ZB is equal to ZC, this is ZC, and that is equal to Z. So the parallel combination ZA I can write by Z, ZC also I can write by Z, and ZB also I can write by Z, and this is VS. So finally what I am going to get, this is A, this is C, this is B, and this point is neutral point. So you can see here that the parallel combination of these two Z will be Z by 2, and this is Z. Now this applied voltage will be divided by the voltage division formula. So this circuit can be made like this, VS, then the parallel combination of Z and Z will be Z by 2, and this is Z. So as per the voltage division formula, the voltage across Z by 2, that is Vs into Z by 2 divided by Z plus Z by 2. So what I am going to get? Vs Z by 2 divided by 3Z by 2. So Z say 2 से 2 cancel, Z से Z cancel. So what I am going to get? Vz by 2, that is Vs by 3. Okay, and this is nothing but it is VAN, because in parallel combination voltage remains same. So it is equal to VAN and this is also equal to VCN. Now if I calculate VZ, means the voltage across this. So again by voltage division formula, it will be Vs into Z upon Z plus Z by 2. So what I am going to get? VSZ 3Z by 2. So it is 2 Z से Z cancel, 2 Vs by 3. So this voltage will be, this is N and this is B. So this voltage VNB, that is equal to 2 Vs by 3. If I calculate VBN, that is minus 2 Vs by 3. So I can write by this that VAN we have calculated Vs by 3, VCN we have calculated Vs by 3 and VBN was minus 2 Vs by 3. In a similar way as 30 to 60 also we are getting the same. So Vs by 3 minus 2 Vs by 3 and Vs by 3. Similarly for the next 162. So 162 when they are going to conduct, so let's see again when the 162 SCRs are going to conduct, this is for 0 to 60 duration. Now let us come to 60 to 120. Next duration is 60 to 120. Now 60 to 120 mein what are the SCRs conducting? The SCRs conducting 60 to 120, you can see that 162. So let's come 162. So what will be the power circuit diagram? 162, that will be like this. This is Vs. 162 means this will be short circuit. This is open circuit. This is open circuit. This will be short circuit. This will be open circuit and this will be short circuit, because this is T1, this is T3, this is T5, this is T4, this is 6 and this is 2, because in this 162 SCRs are conducting. So when I make this equivalent circuit, that is Vs, and this is connected to, and we know this is connected to ZA, this is connected to ZB and this is connected to ZC, and all these three are connected in star. So if I redraw this diagram, through one short circuit, the ZA is connected, this is A, through, you can see now the 6 and 2 are short circuited. So ZB and ZC with these two short circuit are connected to the negative of the supply. So here ZB and ZC, they are connected to the negative terminal of the supply. So this will be the equivalent circuit. So the final equivalent circuit will be like this. Now this is A phase, this is B phase, this is C phase and this is neutral. Now again if I apply the voltage division formula, if ZA, ZB, ZC is equal to Z, if I again repeat the same process, the VAN will be equal to 2 Vs by 3 and VBN, that is minus Vs by 3 and VCN, that is minus Vs by 3. Why minus sign? Because VNB will be Vs by 3 and VSNC will be Vs by 3. But when we write VBN, that will be minus Vs by 3, as we have calculated by voltage division formula in the duration for 0 to 60. So what I can write that now this is minus Vs by 3, this is minus Vs by 3 and this is 2 Vs by 3. You can see here VBN, VAN, that will be 2 Vs by 3. Okay, VAN will be 2 Vs by 3. Sorry, this will be 2 Vs by 3 and these two will be minus Vs by 3, minus Vs by 3. As for 90 to 120, same SCRs are conducting. So the voltages will be same, minus Vs by 3, minus Vs by 3. Then again, if we repeat the same thing, here also you will get Vs by 3, here Vs by 3, 1, 2, 3. When 1, 2, 3 are conducting, then see what will happen. When 1, 2, 3 are conducting, see the power circuit diagram. When 1, 3 are conducting, that means this is conducting, this is conducting, and this is conducting. So means A phase and B phase, they will be connected to positive supply, and C phase will be connected to negative supply, because 1, 3, 2. So A phase with this T1 short circuit will connect to positive, B phase through T3 short circuit will connect to positive, and as T2 is conducting, so C phase with this T2 is connected to negative. So that means A and B phase are connected to positive and C phase is connected to negative. So A and B phase, since two phases are connected to positive, so A phase we are going to get Vs by 3. Here also we are going to Vs by 3, Vs by 3, and this will be minus 2 Vs by 3 and minus 2 Vs by 3. Now similar way, 2, 3, 4. 2, 3, 4, if I talk about 2, 3, 4, that will be minus Vs by 3, minus Vs by 3. This will be 2 Vs by 3, 2 Vs by 3, and this will be minus Vs by 3 and minus Vs by 3. Similar way, if you repeat the same process, the table will be like this. Here it will come minus 2 Vs by 3, minus 2 Vs by 3, and this will be Vs by 3, Vs by 3, Vs by 3, Vs by 3. Then further 4, 5, 6, then it will be minus Vs by 3, minus Vs by 3, it will be minus Vs by 3, minus Vs by 3, and this will be 2 Vs by 3 and 2 Vs by 3. So that kind of table you can make, as I have shown the example between 0 to 60 and 60 to 120. Now you can see here, if I, so these are the phase voltages. All these three are the phase voltages because it is with respect to neutral, and these three are the line voltages, and these three are the line voltages. Now if you want to calculate VAB I can calculate VAN minus VBN. So if I subtract VBN from this, what I am going to get? Vs by 3 minus of minus 2 Vs by 3. So what I am going to get? 3 Vs by 3. So that means Vs. Now VBC means VBN minus VCN. So minus 2 Vs by 3 and minus Vs by 3. So it will be minus Vs. Now what is VCA? VCN minus this. So Vs by 3 minus of Vs by 3. So it will be 0. Now similarly, we can complete this table also. VAB matlab this minus this. So again, I will get Vs minus Vs and 0. Now for the next duration, VAB means this minus this. So what I am going to get? This minus of this. So I am going to get Vs. And VBC means this minus this. So it is coming 0. And this minus this. So it will come minus Vs. So again Vs 0 minus Vs. Now again this minus this. So 0. This minus this. So it will be Vs. This minus this. So it will be minus Vs. So 0 Vs minus Vs. Now again for this minus this. So minus Vs. This minus this. So Vs. This minus this. So 0. Minus Vs. Vs 0. Now this minus this. So minus Vs. This minus this. So 0. This minus this. So Vs. So minus Vs 0 Vs. Similarly for this minus this. So 0. This minus this. So minus Vs. Now 2 Vs by 3 minus this. So Vs. So 0 minus Vs. Now if you observe this table, you can see VAN 0 पे it will be VS by 3. But when we see VBN, the value of VS by 3, it will be at 120. So that means VBN waveform will have the same value as of VN after an interval of 120. So when I plot it, you can see VN is VS by 3, 2 VS by 3, then VS by 3 like this, then minus VS by 3, then minus 2 Vs by 3, then again minus Vs by 3. So it is starting from Vs by 3 and it will go up to minus Vs by 3. So if I plot Vn waveform, now I am plotting the waveform. Now if I plot the phase voltages waveforms, then we can plot like this. This is for A, B and C phases. This is for Vn, this is Vbn and this is for Vcn. Suppose 0, 60, 120, 180, 240, 300 and 360. So you can extend the similar instance for the other two waveforms also. So like this. Now from the conduction table, you can see that the voltage Vn between 0 to 60, that was Vs by 3, and 60 to 120, that was 2 Vs by 3. Then it was Vs by 3, then again it was minus Vs by 3, then minus 2 Vs by 3 and minus Vs by 3. So this is the waveform for VAN. But when you see the waveform for VBN, that you can draw, here it is Vs by 3, here it was minus 2 Vs by 3, then it was having minus Vs by 3, then 2 Vs by 3, Vs by 3, then 2 Vs by 3, then again Vs by 3, then minus Vs by 3. So this is the waveform for VBN. Now at last we will plot VCN. So VCN, here it will be Vs by 3 and here it will be 2 Vs by 3. This is minus Vs by 3. Here it is minus 2 Vs by 3. This is minus Vs by 3 and this is Vs by 3. So this waveform is for VCN and its value will be this. Now you can see as in A phase waveform, the value of Vs by 3 is starting at 0, whereas for V phase, the same wave shape is repeating after 120 degree, and for C phase, it is repeating after 240. So that means the phase difference between the phase voltages VAN, VBN and VCN are 120 degree. That means VAN starts at 120, starts at 0, VBN lags by 120 degree and VCN lags by 240 degree by VAN and VAN. So you can see that it is giving the three phases voltages which are apart by an angle of 120 degree. Now we are going to plot the line voltages, that is VAB, VBC, VCA. So if I plot the waveform VAB 0, 60, or we can write 30, then 60, then 90, then 120, then 150, then 180, then 210, 240, 270, 300, and this is 360. We are supposed to extend. So as you can see from the conduction table, for the starting 120 degree, the value of voltage is Vs, and for 60 degree, it is 0. And again, for next 120 degree means 180 to 300, its value is minus Vs, and then again 300 to 360, its value is 0. So 0. Now if I plot the line voltage waveform for VBC, now VBC, the value of Vs is this, and it will start from 120 and it will continue up to 240. The value is Vs. And then for 60 degree, it will be 0. And then it will be minus Vs. And here also for 60 degree, it will be 0. And this will be minus Vs. So this is the waveform for VBC. Now, the last waveform which we are going to plot, that is we are going to plot for VCA. Now VCA, the value of Vs will be here and it will continue 3 times and here also. Then it will be 0 for 60 duration. This is also Vs, and then for 4 duration it will be minus Vs. And now the next waveform which we are going to plot, that is for VCN, and VCN starting to it's 0, then minus Vs, then 0, and then it will be plus Vs. So you can see here, if I see the line voltages, the value of plus Vs for VAB is starting from 0. And if you see the VBC waveform, the similar pattern will start at 120 degree. And for VCN, it is starting at 240 degree. So what it concludes that VAB, VBC and VCA are displaced by an angle of 120. So that means line voltages are also apart by 120 degree. That means VAB starts at 0, VBC lags by VAB for 120 degree, and VCA lags by VAB for 240 degree. So I hope so. That's the end of three-phase inverter. In this, I have explained the 180 degree mode operation of a three-phase inverter. It is also called as an 3-label inverter. It is also called as an 5-label inverter, because as far as the phase voltages are concerned, we were getting the voltage label Vs by 3, 2 Vs by 3, then minus Vs by 3. Basically, so that's it about the 180 degree mode of three-phase inverter. If we observe the phase voltages waveforms, you can see that it's a 4-label inverter, because in the phase voltages we were getting 4 label Vs by 3, 2 Vs by 3, minus Vs by 3, and 2 Vs, minus 2 Vs by 3. As far as the line voltages are concerned, it's a 3-label. It is having 3 labels. That labels are Vs, 0 and minus Vs. So that's it about the three-phase inverter 180 degree mode. Next time we will, in the next video, I'm going to discuss about the 120 degree mode of three-phase inverter. I hope whatever information I have shared in this video related to a three-phase inverter, especially for a 180 degree mode operation, that will be useful for you. If you like this video, then press the like button, and if you want that such kind of video whenever I make in future, a notification should reach to you, then don't forget to subscribe my channel.